Hello and welcome to GATE Architecture and Planning demo class. I'm Dr. Joshima, representing Atelier Lab Academic Finishing School. This is an initiative by alumni from prominent Indian institutions like IIT, NIT, and SPA. Our online courses are tailored exclusively for architects and planners seeking excellence in their careers. A key advantage of our program is access to highly accomplished faculty with PhDs in specializations like design, sustainability, structural design, construction management, GIS, urban planning, urban design, and conservation. GATE Architecture and Planning and PGTA 2026 coaching by Atelier Lab is scheduled as weekend classes starting from August 2nd. Each session will be of 2-hour duration. A total of 40 sessions are planned with 38 expert sessions and 2 remedial sessions sequenced to cover every topic with clarity. Each 2-hour session starts with a structured theory class to reinforce the concepts and solve sample numericals, followed by a topic-wise mock test and a live test solving and discussion session. Additionally, mock test and previous question papers will be discussed. Reading materials and class recordings will be made available. All classes are delivered live via Google Meet and resources are shared through Google Classroom. Important updates and reminders will be sent via the registered WhatsApp number. Now let's go to the demo class. The demo class is structured as a 10-minute lecture followed by a 5-minute mock test and a 15-minute test solving session. The topic chosen for the demo lays the foundation of our profession, scale and unit conversion. I do not have to say how significant the topic is. An object or a building which is drawn to its actual dimension is said to be in full scale or in a scale of 1:1. Architectural drawings are usually scaled down drawings, reducing the size of the actual object to fit in a paper. An example is 1:2 scale. This denotes that 1 centimeter of the drawing on the sheet represents 2 centimeter of the actual object. Here, the drawing is half the size of the actual object. Another example is a scale of 1:5, where 1 centimeter on the drawing represents 5 centimeter on the actual object. Here, the scaled drawing is reduced 5 times than the actual object. So this is a scaled down drawings where the size of the actual objects get reduced. Certain cases you will require a scale up drawings to show more details, but not usually in architecture or planning drawings. So here the full scale drawing is in 1:1 and a scale up drawing which is represented as 2:1 shows that 2 centimeter on the drawing denotes 1 centimeter of the actual object. So the actual object which is 1 centimeter is getting enlarged to 2 times the actual size. In the case of 5:1 scale, similarly, the actual object which has a dimension of 1 centimeter is getting enlarged 5 times and represented as a 5 centimeter drawing. Okay, so this is about scale and scale down and scaling up. So to wrap up, a scale is a proportion which is used to reduce or to enlarge the size of an object in a drawing. The format is as a ratio. We write it as 1:100 or 1:2, where the first number represents the drawing dimension and the second part represents the actual dimension. When expressing scale, the important thing is that you have to ensure that both numbers refer to the same unit. For example, if the scale is written as 1:100, both 1 should be in centimeter and 100 should be in centimeter. That is an important point to note. Now let's see a few formulas that will help you in scale conversions and unit conversions. As we saw, scale is represented as a ratio between its drawing length and the actual length. This is how you find the scale of a drawing length by actual length, but this is not an actual division, it is a simplification. If you want to change the scale of an area, then it is called scale square or the area scale factor. So here it is drawing area by the actual area. If you want to change the scale find out the scale of a volume given, then the scale cube or the volume scale factor is found out by drawing volume by the actual volume. This is all simplification of the numbers. It is not actual division. Certain questions come where we have to find out the drawing dimension, given the actual dimension of the object and the scale factor or the scale. So the scale factor, if you see, if it is a scale of 1:100, 100 is the scale factor. Okay, so the actual drawing is being reduced or enlarged 100 times. So this is the scale factor. This is one second type of question. The third type of question would be finding out the actual dimensions. So you will be given the dimension of the drawing and the scale where you have to find the actual dimension. Now let's see the formula. So to find out the scale, it is drawing length or drawing dimension by the actual dimension. Find out the area scale factor, it is drawing area by the actual area. If it is a volume scale factor or scale cube, you have to find out the drawing volume by the actual volume. All these things are simplification. In order to find the drawing dimension, given the actual dimension divided by the scale factor, where the scale factor in a scale of 1:100 is 100. Finding out the actual dimension given the drawing dimension multiplied by the scale factor. So these three formulas have to be memorized and becomes handy for scale conversions. So this table shows a few basic unit conversions like 1 centimeter is equal to 10 millimeters, or if you want to find the reverse, that is 1 millimeter is 1 by 10, that is 0.1 centimeter. Similarly, if it is 1 centimeter square, it is 2 times millimeters, that is 100 millimeter square. Or 1 millimeter square is 1 by 100, that is 0.01 centimeter square. Similarly, you have 1 meter, which is 100 centimeter, inverse of it, 1 meter square, 1 meter cube, 1 kilometer, which is 1000 meters, or 1 meter, which is 0.001 kilometer, and likewise. The other two unit conversions, which is very important in architecture or planning, is 1 hectare, which is equal to 10,000 meter square. Here the conversions, because most of the answers they might ask or you will need to convert it into a hectare. So this is a very important unit to remember. Similarly, 1 acre. 1 acre is equal to 4046.86 meters square, or if you convert it into hectare divided by 10,000, which becomes 0.4046 hectare. Okay, so these two units are very important for architecture, and this unit conversion is required while you do the problems. We'll move on to problems. So the first type of problem is finding the scale of a drawing. So you know the scale is represented as a ratio of the drawing dimension by the actual dimension. So here the problem given is the drawing dimension is 3 centimeter and the actual dimension is 600 centimeters. The next check is always the unit check, where you have to check whether both the sides have the same units. Here it is, both of them are in centimeters, so you can proceed to put these two things in the formula. So the formula is, to find out the scale, you have to write the drawing dimension by the actual dimension and simplify it. So this is 3 by 600. If you have to simplify it, that means the numerator has to be made into 1. Okay. To convert the numerator to 1, you have to divide the numerator by 3, whatever number is there. Okay, so you get 1 here. So whatever number you divide the numerator with, the same number has to be used to divide the denominator also. So 600 divided by 3, you get 200. So this is the simplified ratio, which is a scale of 1:200. Okay, so this is how you find the scale of a drawing. Now the second type of question, where you have to calculate the drawing dimension. So you have to find out the drawing dimension where the actual dimension is given and the scale is given. Okay, so always remember that for architecture, where there is a scale down drawings, the actual dimension will always be bigger. Okay, and when you have to find out drawing dimension, which is a smaller dimension, the operation is division. So here you see actual dimension, which is bigger, is divided by the scale factor. Okay, so you divide the actual dimension and then get a smaller dimension. So this formula sticks into your mind because you have to think that the actual dimension is bigger and drawing dimension is smaller, so the operation is division. Okay, so now we'll see the problem. Find drawing area given actual area as 5000 meters square and scale as 1:500. So we need the two parameters. The first one is actual dimension, given in the problem as 5000 meters square. So you write it as 5000 meters square. Now the check. So whatever is given, you have to convert it into your required format. Okay, so the actual area is given in the unit of meter square. So you need to convert this meter square into centimeter square. So here comes the unit conversion formula. Okay, 5000 into 10,000 centimeter square gives you 50 followed by 60 centimeter square. Okay, so this is the required format of the actual area, which has been converted from the given actual area. So the next parameter is scale factor. From the question, the given scale is 1:500. Okay, the scale factor is 500. Okay, and next is you have to convert it into the required format depending upon whether the problem is for a length or an area or a volume. So if the question is for a length, you don't have to convert the scale factor. It is scale factor directly. If it is an area problem, you have to convert this scale factor, square it. Okay, you have to find the square of the scale, which is 250,000. Similarly, if it was a volume problem, then you need to find the scale to the power of 3 to get the scale factor. Okay, so you understand that the given scale in the problem has to be converted into the required format depending upon the question. Now you have both the formats ready in the required way. You apply it in the equation, actual dimension divided by the scale factor, you get an answer of 200 centimeters square, which is the drawing dimension, which is smaller than the actual dimension. The third type of question is to calculate the actual dimension given the drawing dimension and the scale factor. So you know the actual dimension is always a bigger dimension if it is a scale down drawing, and the drawing dimension is going to be smaller, so you need to multiply it to get a bigger dimension. So this is how you remember the equation. So the problem here is a building site measures 96 square centimeter on a scale of 1:12,500. The actual area it represents in hectare in integer is dash. So there is two conversions here. First is you have to find the actual dimension and then convert it into a hectare. We'll go to the first part of the problem, finding out the actual dimension. You need two parameters. We need to find the drawing dimension given in the question as 96 square centimeters Second check is the unit. This is in centimeter, so you don't have to convert. The second parameter is scale factor. Given scale is 1:12,500. You have to check whether you need a conversion or not. This is an area conversion. So you need to find the scale square or the area scale factor, where 12,500 square. This is the scale factor in the required format. So both our parameters are ready. Apply it in the formula. You get 96 square centimeter into the scale factor or the area scale factor gives you the answer. So this is the actual area in square centimeter. Now comes the second part of the question, where it has to be converted into hectares. So centimeter square is initially converted to square meters by multiplying it with 0.001. You get 15 lakh square meters. Now this square meter is converted to hectare. 1 hectare is 10,000 square meters. So you divide the answer by 10,000. You get the answer is 150 hectare. So this is the final hectare as an integer. So you don't need any decimal points. This is the calculation of actual dimension from the given drawing dimension and the scale, also converting it into a hectare unit. Now is the time for a mock test. A 5-minute mock test link is given in the description. You can pause the video, do the test, and then come back and see how the problem is being solved. So if we move on to the test solving, the first question is 1 hectare is equal to dash square meters. So the answer is 1 hectare is equal to 10,000 square meters. The second question is find the drawing dimension in centimeter when an 8-meter long line is represented in a scale of 1:200. So the problem here is we need to find the drawing dimension, which is a smaller dimension. So the operation is division. You need two parameters, the actual dimension and the scale factor. You take the actual dimension, 8 meters, check whether it is in the required format. No, you have to convert it into centimeters. So 8 meters into 100 gives you 800 centimeter. Now the second parameter, scale, is 1:200. The scale factor, check which scale factor is to be applied. Is it a scale factor, scale, scale square, or scale cube? Here it is a scale factor. So you take directly the 200. You get the 200 in the required format. Now apply it in the formula where to find the drawing length, you have to find the actual dimension divided by the scale factor. So actual dimension is 800 centimeter divided by 200, the scale factor. The answer is 4 centimeter. So the drawing dimension is 4 centimeter. This is the second answer. The third problem is a roof area of 6,000 meters square of a building is drafted on a drawing sheet as 240 centimeters square. The scale used in the drawing sheet is 1:dash, rounded off to the nearest integer. This problem is to find the scale used in the drawing. So we need two parameters, the drawing dimension and the actual dimensions. So you take the drawing dimension, which is 240 centimeters square, unit check, centimeter square, correct. Actual dimension 6,000 meters square, unit check, it's in meter square, so you need a conversion. So 6,000 into 10,000, which gives you 600 followed by 5 zeros centimeter square. This is the second parameter in the required format. Now apply it into the formula where the scale or scale square. Here the problem is a scale square. Drawing area by actual area, simplification problem. Drawing area 240 by actual area 600 followed by 5 zeros. So you simplify by dividing 240 by 240. It becomes, numerator becomes 1, and this denominator is again divided by 240. You get 250,000. This thing that you get is a scale square. So the question here is to find out the scale used in the drawing, which is a reduced version. So the scale is root of 250,000, that is 500. So this is the formula application to find out the scale of a drawing given the drawing area and the actual area, where the scale square or the area scale factor comes into play. That's all from me for the demo class. If you have any queries, please type it in the chat box. That means you can WhatsApp me on +918089939570, or reach out to us at our email ID atelierlab.afs@gmail.com. Thank you so much for your attention.